So here's your final exam review. We're only going to be doing the ones that I have circled, like number 1, number 3, how they have that A and B parts. I expect you to do both parts. One like number 13 where it has multiple parts and I didn't need you to do everything that's there, then just do the ones that I have circled. The exam follows this review. In Google Classroom, I have included the solutions to this review as well as a link to a playlist where every problem has been recorded, and you can check out any of the problems multiple times to study. How much time you put into studying will definitely affect your grade on the exam. The exam covers chapters 4, chapters 5, and chapters 8, but the review here is pretty much going to follow everything you need to know. So go ahead and let's get started, and we'll do as much as we can get done during this time. Now, for problem number 1, it says convert each angle measure to decimal degree form. So you might recall that these are our minutes and these are our seconds. Now, those are a part of a degree. There takes 60 of those to make a degree, 60 minutes to make a degree, and then 60 seconds to make a minute, so 3,600 of those to make a degree. So how do you deal with that? Well, you're just going to take, we know the 75 is the start because it's going to be 75 point something. But how do you find the other? Well, you're just going to take 54, divide that by 60, take 30, divide that by 3,600, and you're going to get your answer. Now, the instructions say to round to the nearest thousandth. So we're going to go 3 decimal places. And if we go 3 decimal places, we get 75.908 degrees. Okay? Now, for part B, you will notice technically that's a negative 145 degrees, 0 minutes, and 18 seconds. So we'll see how they have the 2 little tick marks there. So when we do this one, we're going to do a negative 145. Now, this would be negative as well, so just think the negatives on there. And so we're going to minus 18 over 36, just so they all stay negative. And so negative 145 minus 18 divided by 3,600. You can just ignore the negative until the end and put it back on. You get negative 145.005. Okay, so there is number 1. Let's just do number 2A to go the opposite direction. Let's take off the full degrees, and then you just multiply this by 60, so 0.5 times 60 will be the number of minutes you have. And if you don't have, we have no remaining decimal, so that means there would be no seconds. Okay. Now let's look at number 3. Number 3 says to rewrite each angle in degree measure. So remember that 180 degrees is a pi worth of radians. Now it says do not use a calculator. You know, this test is going to be multiple choice. But what they mean by that is don't round, using a calculator. Let's give that an exact answer. And so for 4 pi over 3, we're going to do 4 times 180 divided by 3. And just reduce that down as much as you can. And so that's 240 degrees. Okay? And so this one's going to be 5 times 180 divided by 3, which is 300 degrees. Now let's go the opposite way. Let's add a little C part here. Let's say that we have 100 degrees. And we want to go, well, how many radians is that? Well, you're going to just do 100 pi over 180. That's an exact answer. Don't use a calculator. Or if you use a calculator, make sure that you keep that pi as an answer and you reduce 100 over 180. Well, 100 and 180 are both divisible by 20, and if you divide it by 20, you get 5 over 9, so that's 5 pi over 9. That's the exact answer I'm looking for. Let's do number 4. Number 4 says to find the length of the arc on a circle of radius r intercepted by the central angle theta. Now, you might want to know that arc length, the formula is r theta. So, you know, facts like 180 degrees is pi radians, s equals r theta, those are things you would probably want to include on your review note card. So what do we have to do? Well, in 4a, the only problem is our theta should always be in radians. So let's make 240 pi over 180 and reduce that as much as possible. Well, 240 pi over 180 is the same as 4 pi over 3. They're both divisible by 60. So the arc length for A is 13 times 4 pi over 3. Now, if your answer says exact length, you just do 13 times 4 times, just leave the pi in the answer, divided by 3. So 13 times 4 is 52, so the exact answer is 52 pi over 3 inches, because our original was inches. So that would be your exact answer. Now, if they wanted to know your answer, say, to the nearest tenth, you'll notice that maybe it's a multiple choice and the answer was rounded. Then you're just going to do 52 times 3.14 divided by 3. Let's move this over a little bit. And so you get an answer, let's go to the nearest tenth, to 54.4 inches. Okay. Now what's great about 4b is theta is already in radians, and so the arc length here is just 3 times 1, or 3 meters. Okay. Let's take a look at the area of a sector. It says here for number 5, find the area of a sector of a circle with a radius r and intercepted by a central angle theta round to the nearest hundredth. So they do want us to enter this into a calculator. The formula you would want here is area equals 1/2 r squared theta, where r is our radius and theta is our angle measure, and it must be in radians. Okay, must be in radians. Okay, so let's do part A. So the area is going to be 1/2 15 squared times pi over 3. Now, because they mentioned that fractional, pi over whatever, that is giving us a good indication that you're going to use 3.14. So when they say that, use your 3.14. And so we've got, let's see here, 1/2 times 15 squared times 3.14 divided by 3. And we get 117.75 square inches. Now, why is it square inches? Well, area is a square unit. Our original units were inches, so we're going to use square inches. Now let's go on to B. We have our radius, but this time our angle measure is not in the correct form. So we know this is 225 pi over 180. Now, if you want to reduce that, go for it. But it's not necessary because we have to enter it into a calculator anyway. So the area for this one is going to be 1/2 1.5 squared times 225 pi over 180. Again, like I said, if you wanted to reduce that, you can. You know, if you knew what it was from the unit circle, go for it. So what do we get? Well, 1/2 times 1.5 squared times 225 times pi divided by 180 is approximately, to the nearest, what did it say, hundredths, 2 places, 4.42 square feet. Why square feet? Well, the original was feet. This is going to be square feet. Okay. Let's take a look now at number 7. Now they say to find the exact values. We're going to assume that this is a right triangle, so please put that little mark there for me. You shouldn't assume that unless I have drawn that little mark in the thing or told you otherwise. This is a 30, 60, 90 triangle. When that's the case, you can use your special triangle rules, or we can use SOHCAHTOA, so either one. The special triangle rules are going to help us for a 30, 60, 90 and a 45, 45 right. Let's go over those. We'll do it 2 different ways to show you kind of, but let me go over the 30, 60, 90 rule. That sure doesn't look very good. Okay, let's see. So let's say we have a 30, 60, 90 triangle, and we know the side across from the 30 is x. Then the one across from the 90, the hypotenuse, is 2x. The one across from the 60 is square root of 3x. Okay? And so that's a little rule you can use. If we have a 45, 45 right triangle, and if we know the ones across from the 45s are x, the hypotenuse is always square root of 2x. Okay? So we can use those rules to find some exact information. Now, let's look at what we know. We know the hypotenuse, and we know that it is always going to be double the one across from our 30. So if this is 26, then this has to be 13. Now, what's another way we could have done it? Well, if we wanted to relate x and 26 to angle 60, we know that the cosine of 60 is x over 26. Well, if you go to the unit circle and find the cosine of 60, it's 1/2. And if you cross multiply, you get 26 divided by 2, or 13. So that's another way to do the problem. Now, how do we find the one across from the 60, the y? Well, if we know the one across from the 30, if you look, you got to take off the 2 and replace it with a square root of 3. Well, how do you take off the 2? Well, you divide by 2. And so that's why this one becomes 13 square root of 3. Now, what's another way we could have done that? Well, we could have said the sine of 60 is y over 26. Well, what's the sine of 60? Well, on the unit circle, the sine of 60 is square root of 3 over 2. If we multiply that by 26, because we cross multiply, we get 13 square root of 3 is 1. So there's lots of ways to do that. But knowing these little facts, maybe write those down. That might be helpful, okay? Okay. Let's take a look at number 9. So number 9, I'm going to add a sheet of paper here so I can draw the picture for you. Okay, let's read number 9. It says the point -7, -2 is on the terminal side of an angle theta in standard position. Determine the exact values of the 6 trig functions of theta. So, anytime they ask you to do a problem like this, the first step is to always make your xy axis. That's your first step. Then I want you to draw the point's location. Put the point. Okay, so we're going to go 7, so 7 to the left. And then a negative 2 is going to bring us 2 down. Now, no matter where you are, the next step is always to connect that to the origin. And then the step after that is always to connect the point to the x-axis, always to the x-axis. And then our right angle is here. Our theta is always the angle closest to the origin. Okay, so we always do that. Find the point, connect it to the origin, connect it to the x-axis, build your triangle. Okay. Now that we've done that, let's label. This is -7, this is -2. Our hypotenuse will always be positive. Remember that. The only thing that might have a sign on it are your x's and y's. Your hypotenuse will always be positive. So how do we find that hypotenuse, which we're going to call r? Well, r squared is going to be -7 squared plus -2 squared. So r is going to be the square root of -7 squared plus -2 squared. Well, -7 when you square it is 49. -2 when you square it is 4. So that's going to be 53. Okay, so let's put that on there. Again, it is always positive. Now, how do we build the 6 trig functions? Well, it's just SOHCAHTOA. You might want to put SOHCAHTOA down. I'm going to write the original 3, sine, cosine, and tangent, in SOHCAHTOA order. And I'm just going to use this. Now remember, if you actually label, the x is our adjacent, the y is our opposite, the r is our hypotenuse. And you're just going to SOHCAHTOA it out there, okay? So what do you get? Well, sine is -2 over square root of 53. We'll worry about rationalizing that. The cosine is -7 over square root of 53. The tangent is opposite over adjacent, -2 over -7. Now, let's pretty them up a little bit. This is -2 square root of 53 over 53. -7 square root of 53 over 53. And here, the only thing that happens, the 2 negatives can cancel. Now, once I have my 3 original SOHCAHTOAs right next to them, they're reciprocals. So it's going to be cosecant, secant, cotangent. And then just flip over. Now, flip over whatever version you want. I think the best ones to flip are probably this one, and this one. But just flip them over. Find the reciprocal. And so this is going to be negative square root of 53 over 2. Now, traditionally, you just pop the negative to the top no matter what. This is going to be negative square root of 53 over 7, and this is 7 over 2. Okay? So there is number 9. Now let's do number 11. Now, number 11 says, evaluate the sine, the cosine, and tangent of the following measurements of angle beta without a calculator. Now, all that means is when they're talking about stuff like that, we're talking about unit circle. We're talking about using the unit circle. So let's start with 300. On the unit circle, 300 is the reference angle in the 4th quadrant, so with 60, so it's down here. The point at 300 is 1/2 negative square root of 3 over 2. The x is positive and the y is negative in the 4th quadrant. So now we know everything we need to get the sine, the cosine, and tangent. Well, the sine of 300 is the y value, negative square root of 3 over 2. The cosine of 300 is the x value, 1/2. Now the only one we really have to do any mathematics for is the tangent. Now remember, the tangent is going to be the y value over the x value. So it's going to be negative square root of 3 over 2 over positive 1/2. Well, positive divided by negative is a negative, so we know the answer is going to be negative. 2's are going to cancel. It's just going to be negative square root of 3 over 1, which is negative square root of 3. So there's your answer for part A. Now let's do the same thing for part B. This time our beta is 5 pi over 6. If you forget what that is, you can do 5 times 180 divided by 6. And you can see that that's the same as 150 degrees. 150 degrees has a reference of 30. It's in this second quadrant. There's 150. And the point at 150 is negative square root of 3 over 2, positive 1/2. So let's do the sine, the cosine, and the tangent of that. Well, the sine of 5 pi over 6 is the y value, 1/2. The cosine of 5 pi over 6 is the x value, negative square root of 3 over 2. And the tangent, we have to divide them. So this time the 1/2 goes on top, and the negative square root of 3 over 2 goes on the bottom. So we still get a negative. This time the 2's still cancel, but this time the 1's on top, and the square root of 3 is on the bottom. Now normally we don't leave it like that. We rationalize, and how does that work? Well, you pop the square root of 3 on top, and a regular 3 is left behind. So your final answer for the tangent of 5 pi over 6 is negative square root of 3 over 3. Okay? So I think that gives you a nice start on some things to study. And then we're going to continue this as much as we can.